Now let us try to understand what are the bandwidth requirement for TDM PCM system. So bandwidth requirements in TDM PCM system. So if I consider only the TDM system, in TDM system, let's take n number of signals to be transmitted, each with bandwidth of, let's say, fm1 comma fm2 up to fmn. In that case, the total bandwidth of TDM signal, the bandwidth of TDM signal, this we have already defined before, will be nothing but half into fs1 plus fs2 plus fsn, where fs is nothing but the sampling frequency used for each and every signal. Now the same thing in TDM PCM system, because now PCM comes into picture, we have to talk about quantization. So let's say capital N number of bits, so we are assigning capital N number of bits per sample. Now if we do that, then the bandwidth of TDM PCM signal will be nothing but every sample is now transmitted in the form of n number of bits. So in case of TDM signal, let's say if I was transmitting x number of samples, in case of TDM PCM system, I'll be transmitting n into x number of bits. So x were the number of samples, and now n into x will be number of bits, because I'm giving n bits per sample. So the bandwidth of TDM PCM signal will get multiplied by capital N. So it becomes n into half into fs1 plus fs2 up to fsn. So this much is the bandwidth of TDM signal. You are multiplying by n because now you are transmitting n bits per sample. So in case of TDM PCM system, if let's say we have all the bandwidths equal, if fm1 is equal to fm2 is equal to, let's say, fm, and let's say the sampling frequency that we use are also exactly same for all the signals equal to fs, then what will be the total bandwidth? In that case, bandwidth of TDM PCM signal will be equal to capital N into, you can see I'll keep this half as it is, fs1 fs2 everything is equal to fs. So we have n times fs repeating. So if you add the same value n times, it will be n into fs. So this whole thing can be written as capital N into small n fs by 2. So small n fs by 2 will be nothing but bandwidth of TDM signal, and you are multiplying by n, capital N, because of the PCM part of the system. You can see if the sampling is done at Nyquist rate, fs will be 2fm, 2 will cancel out, the bandwidth will be n into fm. But it is always good to mention bandwidth in the form of sampling frequency, because in practice we always sample the signal at a rate greater than Nyquist rate. So that's the total bandwidth of TDM PCM system. So just to get an idea in terms of numbers, let's say for example n is equal to 10, we are transmitting 10 signals. Fm, that means the bandwidth of each and every signal, is equal to, let's say, 5 kilohertz. But I'm sampling the signal at the value of, let's say, 12 kilohertz. I can sample at 10k also, but I'm using the value greater than 10k, which is 12 kilohertz. In that case, bandwidth of TDM signal, if I only consider TDM signal, it would have been n fs by 2. So n is here 10, fs is 12k by 2, and this will be nothing but 60 kilohertz. If I use sampling frequency of 10 kilohertz, in that case the bandwidth would have been 50k. But because I'm using sampling frequency of 12k, I have to consider this modified formula. This is the bandwidth of TDM, so it becomes 60k. But if I consider bandwidth of TDM PCM system, then I have to consider capital N. So let's say I'm assigning 3 bits per sample. So if n is equal to 3, then the total bandwidth required will be 3 into 10 into 12k by 2. This is the formula I'm using, and that will come out to be 60 into 3, which will be 180 kilohertz. So you can see the bandwidth requirement for the transmission of digital signal in the form of number of bits will be very large compared to transmission of the analog signal. That's one drawback of digital communication, that the bandwidth requirements are large. But there are many strong advantages of digital communication, which is in the form of noise immunity and many other things, which make digital communication preferred over analog communication in many applications.